welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 140, word break 2. Two things before we read the question prompt. First one, subscribe to the channel. I want to grow. You guys know the drill. The second one is if you haven't seen the video for word break 1, please go watch that video because a lot of the concepts that we use there, we're going to use here. And this question is a lot harder, so you definitely want to know how we did that problem before watching this one, otherwise you might be confused. That being said, let's read the question prompt. Given a string S and a dictionary of strings word dict, add spaces in S to construct a sentence where each word is a valid dictionary word. Return all such possible sentences in any order. Note that the same word in the dictionary may be used multiple times in the segmentation. So we have our input string S here, cats, well, it's cats and dog, and our word dictionary is cat, cats, and sand, dog. So basically we want to find out what are all the possible splits. In word break 1, we were just wondering, can we actually split this? This question is a lot more annoying because we have to find all possible splits that are valid, which means that we're basically going to have to do this in a DFS manner, exploring all paths and checking whether or not they're valid. But let's kind of go through this in the same way that we did the other one. Remember, we're going to parse from left to right and we're going to check whether we can make a split. So we have our word, cats and dog, and we're going to go through our dictionary to see what are all the possible splits. So can we split on cat? Yes, we can. So if we split on cat, so let's just write our word here, cats and dog. So if we split on cat, then we know that we'll be left with sand dog, right? Sand dog, right? And then we can explore this further and we can do that. So sand dog, what can we split on? And remember that we can reuse words as much as we want. So sand dog, what can we split this? Well, we can split this on, can we split it on cat? No. Can we split it on cats? No. And no, because it doesn't start with and, so we can't split it like that. Remember, we're breaking it. It's not whether or not the string is actually literally in there. So can we do sand? Yes, we can. So we can chop sand off of here. And then we're just left with dog. And then we check, okay, can we split on cat, cats, and sand, dog? We can split on dog. And like in the other problem, we were left with an empty string, which means that we have a solution. So our valid splits here were cat, sand, and dog. So like you can see, that is one of the answers that we expect here. Now, let's continue from the original string. So we explored that entire path completely by splitting on cat. But remember, there's still other things we can split on. So this word, can we split it on cats? Yes, we can. So we have our original word, cats and dog. And then we split on, let's see, cats, right? So now we're left with and dog. And let's see, can we continue further? So can we break this using cat? No. Can we break it using cats? No. Can we break it using and? Yes, we can, because we can put this place right there. So we put and now we're left with dog. And now, as you can see, we're back at dog. And we've actually already computed dog, which tells us that we're probably going to want to use some sort of memoization to make sure that we don't actually duplicate things, because we could get duplicate words and we basically want to check whether or not we can split them or not. So, you know, we could go down the path of checking all of them again and figuring out that this actually is a valid split by splitting on dog, and then we're left with an empty string, which is a solution, as you can see, cats and dog. Or if we have a memo dict, we can say dog, and then we can, you know, have like a list of all the valid splits after that, which is what we're going to be using to actually build our solution. So we're going to want to maintain this memo dict to actually solve this. So that's like a very basic example, but let's think about how we're actually going to build this out, because it's really easy to just go through it visually, but we need to write an algorithm to code this up. So let's kind of erase all of this stuff here and think about how we might build our algorithm to kind of get like an intuitive sense of how to solve this. We looked at a simple example and we talked about how we're going to use DFS plus memoization here to actually solve this problem. And the reason that we're going to do this is because, you know, we're basically splitting this up into smaller and smaller pieces. So, you know, we have our original string, cats and dog, which is really, okay, so if we split on cat, you know, this is splitting on cat, and then we're doing the same thing for sand dog that we did with cats and dog, except for now we have a smaller string. So basically, as you can see, we are making smaller and smaller problems here. And when we split on sand, we're gonna have now dog. And the process of finding whether we can split dog was the same algorithm we used for sand dog and cats and dog. So as you can see, we're using a divide and conquer strategy where we're trying to break it down into smaller and smaller pieces each time. So obviously, this is DFS. We're just gonna explore all the paths recursively until we actually get to an empty string, which means that we were able to, come to a solution. Now, it's not good enough like it was in word break 1 just to say, okay, whether or not we can split it. Remember, we have to return all the possible splits and, build them out as strings. So instead of returning true from every time we call our function, we're basically going to have to return a list of all of the words that we could actually, create by splitting there. So after we split on cat, we would expect sand dog to return a list of all the, valid splits after it. So then we split on sand here, somehow that's sand, and then we get to dog. So, here we would do the same thing. So once we get to this, obviously there's nothing to be returned there, so we just return an empty string. From dog, the only valid split from dog is going to be dog itself. And then from sand dog, we use the split that we just had sand, and then we're going to add that to like the solution that we got back from calling it on dog, which is just dog. So we're going to concatenate these two strings with a space in between them. As you can see, there needs to be a space here. And then we're going to send that to basically cats and dog, and then, keep going. So that's how we're going to build it. And I don't want to get too much into the weeds here drawing it out, because as you can see, it's really messy. And I think the easiest way to do it is actually just going to be for us to go to the code editor. And believe it or not, this entire solution is only about 20 lines of code. It's really simple, but there are some bits where you kind of need to think about it a little bit. You may need to draw it out on your own. Obviously, I don't want to get it too messy. I have a limited amount of space here. I'm drawing with my mouse. It's just going to be painful for both of us. But we're going to go to the code editor. We're going to type out, the solution. I'll walk you through it line by line, explaining why we're doing what we're doing. And hopefully by the end of it, it clicks. If it does, great. If it doesn't, go through the example with the actual code and see how it works. All right, so enough blabbing. Let's go to the code editor and actually type this out. Okay. We are back in the code editor, and let's type this up. Like I said, it's actually not that complicated of a solution. You'll be surprised. It's only about 20 lines of code. So remember that we're going to be using a depth-first search manner to solve this question, because we need to explore basically all the possible splits at any given time. And what we're going to need to do is we're going to use memo here, because as you saw in the example when we drew it out, we actually get words that we have encountered before, so we can basically memoize this and save us from computing it again, because obviously with DFS, if you explore every single path, there's bound to be some sort of duplication, and we want to optimize our solution by not redoing those calculations. So let's set up our memo dict, which is just going to be a simple dictionary. And now let's write our DFS function. So we're going to say def DFS, and this is just going to take our string, right? So we're going to pass in our string, and you'll probably want to use a different variable name if you're not in Python, because that's probably a type in whatever language you're using, but in Python, we use str instead of string, so we can get away with that. Anyway, so what we want to do is, the first thing we want to do in our DFS function is actually check whether or not we've computed the word break for this actual string before. If we have, we can just return it right away. There's nothing for us to do. So we're going to say if string in memo, then we just want to return memo of string, right? Simple as that. Now, what happens if our string is empty? We know that from the example, when we get an empty string, that means that we were able to split our entire original word S using the words in the dictionary, or I guess break it using the words in the dictionary. And this means that we've actually converged at a solution. And remember that we're not returning true or false whether or not we can split our string here or break it. We are returning all the possible breaks from that position onwards. So if we get to an empty string, obviously there is nothing left. So we just want to return a string with, a list with an empty string in it. So we're going to say if not string, we're just going to return a list with an empty string, and you'll see why we do that in a second. So Now what we need to do is we basically just need to try all the possible splits, which is going to be going through our word dictionary and basically checking whether or not our current string S starts with that word. So we're going to say for word in word dict, we're going to say if string dot starts with the word. So basically, if that string starts with the word, that means that we can break it, and therefore we can continue down our tree. So we're going to say all the subwords that we can get from breaking this word is going to be equal to calling DFS on our string, but obviously now we need to slice it because we're taking that word and we're slicing it from that word onwards, because obviously we could break it because it starts with it. So for example, if we think of our thing, it was like cats and dog. So obviously, we're going to try cat first, and we can see that this string starts with cat. So we're going to slice everything to the right of cat. So that's going to leave us with sand dog, right? And then we're going to repeat the process, right? And we get sand, so we try to split here, and that's basically why we're splitting it. So it should be pretty clear there. So those are going to be all of the words that we get when we actually split. And actually, I did forget one thing here. We're actually going to need a local result here to actually store all the words that we can build once we actually call this DFS and it returns our value. Because remember, we are returning a list, so we're going to need this to basically store all the possible words that we can get. So we've now called our DFS function on the word that we had on our string, and then chopping the word that currently starts with it. At this point, we need to start building our result. And remember that in our result, basically all the splits, they need to have a space in between them. So we need to actually add that space because they won't be present when we actually return them. So we actually need to build those out. So we're going to say for subword in subwords, what we need to do is we need to basically add this to our local result. So it's going to be local res.append. So what we're going to do here is we want to add to this list, what is it? So obviously, like we have in our example, if I can just go down here, right? We had cats and dog, right? So we split on cat, and then we called DFS on sand dog, right? So this is going to return that we could split on sand and dog. So now we need to add our original string cat with the rest of this to build our solution. So what we're going to do, because we need to return the string cat, why is there a space here, cat sand dog, right? So we need to say we want to return our word, because remember our string that we started the DFS with starts with this word, so we need to return the word plus. Now if our subword is actually a word, then we want to add a space to it. But remember that it's possible for our subword to be an empty list, so we need to take that into account, right? We wouldn't want to add a space at the end of dog, because dog was the last split. So obviously we don't want to add that split if this word is the actual one, the last one, which is going to be the case when we get this empty string here passed back to us from our DFS function. So what we're going to do here is we're going to have a little if statement. So we're going to say we're going to add an empty, a white space if subword. So basically, as long as subword isn't an empty string, which is this case here where, we had cats and dog, right? Cats and dog. We split on cat, then we split, sand dog on sand, and then we get to dog, then we split on dog, and now we're left with an empty string. So obviously we would just return the empty string, but like I said, we don't want to add that space to the end of dog. Dog should be the last word, so we need to take that into account. So if the subword basically isn't this empty string here, which is going to be returned to us in that kind of base case here, then we want to add a white space. Otherwise, we're just not going to add anything. We're just going to add just an empty string there. And then what we want to do now is we want to add the subword, because remember the subword is going to be the the concatenation of whatever the previous splits were. So when we split on cats and dog on cat, when we call cat sand dog, this is going to return a list which has sand dog in it. So we just need to concatenate these, right? So with whatever the remaining words are, so we just say subword, right? So subword. Cool. So that is going to be what we're going to add to our local result. And then remember that we want to memoize these results so that way we can reuse the results. So let me just get back in here. So once we exit out of our for loop, now we can say memo for our string that we started with. We're going to assign it to local res. That way we can reuse the result if we ever see this string again as part of our DFS. Last thing we need to do is simply return the local res, and we are done with the DFS function. Now all we need to do is return DFS on S, and that will actually give us our solution. I just want to run this, make sure I haven't made a bug, because this one is a little bit complicated and it looks like it works. Okay, cool. Let me just submit this, and cool, it works. So let's now think about the time and space complexity. Okay, so we coded up the solution. Now it's time to talk about the time and space complexity. So this problem is really tricky to get this part right, and I might even make a mistake here, so I'm open in the comments if you guys want to discuss what the true time complexity is, but this question is really, really tricky. So my best estimate of it would be this. So let's think about the worst case scenario for our word break. We're gonna have some string, you know, whatever characters are in it, right? In the worst case, our word dictionary is actually going to contain the English alphabet, right? Like A, B, C, D. And since all of our characters in S are obviously characters, that means that we can split S, 26 times, or however long, we can always split it because our word dictionary contains the actual English characters. So we'll always have a split. So the amount of solutions we're going to have is going to depend on, however long S is. So obviously, when we get to a branch in our DFS, we have a choice, right? Either we take a word and split it, or we don't, which means that we have, in the end, two to the end decisions to make, right? To take or not to take, right? So that is going to be the first part of our time complexity, which is, this part where we actually do the DFSing. Now, we also have to basically build the subwords. And remember that we said in the worst case, we're just going to have English characters in our word dictionary, which means that this one is just going to be pretty much the entirety of our the rest of the string, right? Because we can keep splitting it. Therefore, we're going to have a ton of results in here. So this part is actually going to be big O of n squared. So for every subword, we then have to build this part. So obviously, this is a big O of n operation. Then we have to do these concatenations here, which is also going to take big O of n. So our time complexity in the end is going to be, 2 to the n plus n squared. So this is a, exponential solution. But, given the complexity of the problem, luckily we can bring it down using memoization, but this is kind of the worst case scenario. And the space complexity is going to be the same idea, right? We could have potentially 2 to the n solutions, 2 to the n solutions, right? And that is for every, possible, sorry, not for every possible word. So we have 2 to the n solutions here, which we know that we have, right? And we're also going to need to store all of these solutions in local res. So, storing, this local res here is going to be, n squared space because, for every subword, we could potentially have the rest of the string made up in our worst case here. So again, we end up with basically what is a, exponential solution. So like I said, this time and space complexity is really hard to nail. I think I probably may have made a mistake here with the space complexity. There might be an additional factor. I think it might actually be multiplied by n because for every character there are potentially 2 to the... I'm not entirely certain on the space here. The two solutions the Leetcode does are actually dynamic programming ones, and you guys know that we don't do dynamic programming here, so I can't actually figure out the one for this algorithm. But I believe it should be 2 to the n, just because of all the splits you have, and then we also have this building part here. So I mean, it's definitely an exponential solution given the, you know, backtracky nature of it. And then there's two options at each time. Obviously, we take or don't take, so either we break or we don't break. Because of that, it's 2 to the n, but there may be some extra ones here, but I think this kind of nails it. So this part is basically just the decision on whether to break or not, and then this n squared is going to be for actually building our kind of local res here. And then same with the space, right? We need to, you know, potentially store all of these solutions, and then we have this local res part, which is going to be, you know, storing all of these temporary ones, and then also whatever is in memo. So I think that is your time and space complexity. Like I said, the space one might be a bit off, but I think for time, it's definitely exponential. This exponential part will eat over this quadratic part here, so we can kind of ignore it asymptotically, but it's for sure an exponential solution. And because there's only 2 possible options at each time, split or don't split, it's 2 to the n, so that should be kind of like a base one there. Again, this is a really tricky problem. The algorithm is really easy to write, but like I said, the time and space complexity is a little bit tricky. So if you guys have any better ideas, please leave it in the comments below. Otherwise, that is going to be your solution. I'm going to end the video there. If you enjoyed this video, please leave a like and a comment. It really helps me grow the channel because it helps the YouTube algorithm. If you want to see more content like this, drop a sub and let me know in the comments what problems you want to see next. Otherwise, thank you so much for watching. Bye.